Hey guys, welcome back to my video series on solving LeetCode problems. In this video we're looking at the problem which is copy list with random pointer. I recorded a video where I came up with a solution. Here's the paint. But, well, it was too long, it was 30 minutes, so I want to make something shorter. So I'm re-recording everything. So, what's this about? Copy list with random pointer. So we're given a linked list, which is val and next, but this one has a random. So it has some examples here. So you can see that this one connects to this one, this one, this one, this one, but it also has a random pointer that connects to either null or to another position, which is, it's a funny thing. So we need to create a copy of this. And how do we copy this? So we need to create a new copy, and in memory needs to be entirely different. It cannot be the same objects or pointing to the same objects. It's mentioned over here. Brand new nodes. We need to do a deep copy. So how do we do it? So this was my idea. Let me delete this. So let's imagine we start with something like this. And it's 5 connects to 9. Well, normally it does. This is the next. But it also connects randomly to 2. 9 connects randomly to 5. And then 2 connects randomly to nothing, to none. No. So, let me move my camera to this side. I thought the idea that I came up with was, let's create another copy, but just with no randoms. So we create a copy list by iterating the list, and next ones we create nodes like this, 5, 9, and 2. But we also save in the dictionary. So dictionary of position and node, we save the thing. So position 0 equals node, that is 5. Position 1, it's the node, that is 9. And same thing for the last one. The second position is the node, that is 2. So we just like link the objects. This object goes here, goes to this position, this object goes to this one, like this. Okay, then we iterate again over the original linked list, and we replace the values by their indexes. So 0, 1, and 2. Okay? And now, done. So what do we know now for sure? We know that each of the values of all the elements of the list are different from each other. Because we didn't know that before. We could have like 5, 5, 5. That was possible. But now we don't. They're all different, and they represent the index. So we iterate over it again one last time. So we go and say, hey, 0, I'm at 0. Let's check what my random, what's the value of my random connection. It's 2. Oh, nice. So that means that here, the random value of this, the new node of position 0 is the node of position 2. So we just compare val with val, and this we use the references on the dictionary. So yeah, cool. Now we know this. Of course, yeah, we already had connected them like this. So then 9, we get to the second one. The one on position 1 connects to one on position 0. Nice. So position 1, position 0. Good. And then the same thing with the last one. We check that the node on position 2 connects to nothing. And we came up with a copy. So this is exactly like the original. So let's get to implementing this. So I created a case which was node 2, node 9, node 5, and next equals node 2, and random equals node 3. So this is the first connects to the last, the second connects to the last. Actually, the difference is that in this case the 9 doesn't connect to 5, it connects to 2. I just did it that way here. And let's go. So first we create a copy. We just create a copy. So while current head equals head. New head equals none. So while current head, we create a new node, and it's equal to current head dot val, and that's it. New node. It's just a new node, and new head, and also new current head equals none. So we have a new node, and if we say, now we go and see if new head is none, then we say new head equals new node, and also new current head equals new node. And now, else, new current head dot next equals new node, and new current head equals new node. Okay, so, and now we do current head equals current head dot next. Let me just put a breakpoint here and check if everything is fine. So new head is 5, next is 9, next is 2. Perfect. Let me just check an edge case. So what if I don't have like pretty much anything, and that's it. New node 5. New head is 5 and nothing. What happens if, okay, this is good. So let me just do, no, okay, good. I'll deal with other edge cases later. So one thing left to do is check new nodes by position, which is a dictionary of ints and nodes, which is equal to empty. And now we just go and say, hey, at the end, new nodes by position of index equals new node, I guess. Yep. New node. I think that's it. Of course, index, we don't have an index here, so index plus equals 1, and we start with index equals 0. Okay, so let's rerun this. New nodes by position 0, 1, 2. Position 0 we have 5, position 1 we have 9, position 2 we have 2. Perfect. So now let's iterate over the original head and replace the vowels with index. So index equals 0, while current head equals head, while current head, whoops, current head of value equals index. Current head dot equals current head dot next. Index plus equals 1. And now, what do? We write, now let's iterate over the original and change randoms of the new ones. So, same thing, but we do something like this. If current head dot random, then we use our dictionary, which is new nodes by position of index dot random equals new nodes by position of current head dot random dot val. And then we reach the end, and that's it. So let me print. Now we return new head. I think it's new head that we want to return, right? Yeah, new head, yeah, I think it's new head. So let me run this. New head starts with 5, then it's a 9, and then it's a 2. And the random should be a 2. A none, okay. Next, random 2, okay. I'm going to submit this, but this will fail because of an edge case. And I will get to it. Well, it worked actually. I was expecting an edge case, but well, perfect. I hope you guys enjoyed it. See you later.